Hi everybody, today we're going to speak about the physics of cycling. So, let's start to highlight the three main forces that interact with a biker, with a rider, and they are gravity, rolling resistance, and aerodynamic drag. So, let's start with gravity. Gravity can work with us if we go downhill, for us if we go downhill, or it can work against us if we go uphill. There are two main variables that influence gravity force, and they are gradient and the total weight, the bike weight plus the rider weight. The formula to express the gravity force is this one, and we can start analyzing each term in the formula. So the first term is the gravitational constant G. This is 9.8067. This is equal in each part of the Earth. If we go to the moon, it's different, but it's quite difficult that you go and have a ride on the moon. The second part is the gradient part. It looks quite difficult, but it simply transforms the gradient, so 1%, 2%, minus 5%, into the vertical delta. So we can know, if we have a 10% gradient, we can know how much we go up or how much we go down in the altitude. And the last term is the rider wave, and plus the bike wave, and we indicate with a W. Now we move to the second big force that in this case always work against us. it is not helping us, and this is rolling resistance, and it is also influenced by gradient and total wave. The formula is similar to what we've seen before, but so we have this gravitational constant G again. Then we have this part that it takes into consideration gradient. In this case, we are interested not in the elevation, in how much the altitude changes like before, but in this case we want to know the horizontal movement that we have. So if the gradient in this case is 0, all this part will be 1. But if the gradient is below 0 or bigger than 0, this part will be less than 1. So it will just consider the horizontal movement. The third term is W again, that is the rider wave plus the bike wave. And then we have a fourth term, in this case is the coefficient of rolling resistance. And in this case, usually to find this coefficient we need to know which bike tire we're using. There are websites where you can find this coefficient, and it's usually very, very low, but once you find your coefficient, it's always that, so you don't have to worry about it. And the third biggest force is the aerodynamic drag, and it is influenced by the frontal area. So let's say you're riding, and the frontal area is the part of your body that is going toward the hair in front of you. If you look the rider, it will be the face, the chest, and so on. And then the airspeed. Airspeed, we just have to clarify this, is the ground speed, so the velocity we are riding. Maybe we're riding 20 miles per hour, 25 miles per hour, plus the headwind. So if we have headwind, we should increase, if we have headwind that is 5 miles per hour, 10 miles per hour, the total airspeed will be the ground speed plus the headwind speed. If we have tailwind works with us, it helps us, so the total airspeed will be lower than the ground speed. And to calculate the aerodynamic drag, we use this formula that it starts with 0.5, this is a constant, then times the drag coefficient. The drag coefficient is the most difficult thing to find. There are online, you can find some good estimator there, but I think we can do a video to find your drag coefficient simply using your data. If you have power data, the gradient, and so on, I think it's quite easy to find your drag coefficient. Your drag coefficient also changes based on the position on the bike, changes on what you're wearing, and so it's a complex argument. In this case, we just take we just consider a constant basic drag coefficient that can be like 0.5, 0.55, 0.6. That it's a reasonable drag coefficient that we may find as a rider. Then we should multiply this by the frontal area, what I explained before. So it's the part of your body that is going towards the hair. And then air density. The air density, it's easy to find in this case because you just have to consider your altitude, and that's enough usually. Then if you want to be very, very precise, you should also consider how much water there is in the hair, and so you should consider the weather as well. But I think that considering the altitude is good enough. And then we multiply the airspeed twice, so we have airspeed squared in this case. So the total forces that work against us or with us are the sum of all these forces. And so to know all the forces, we should just sum together the gravity force, the rolling resistance force, and the drag force. And we know all the forces that work usually against us in a bike ride. And we know these forces. We want to know how much power we need to put into the wheels to overcome these forces. And in this case, to know how much power we need, we just need to multiply the forces that we calculated before times the ground speed we are using. That's quite, I think, clear to understand. We have these forces. If we're going at 10 miles per hour, we should put a certain amount of power. If we got 20 miles per hour, we should double this amount of power, and so on. And but let's say that the power that we use is not exactly the power that goes into the wheels, because there is a drivetrain loss, so not all the power it goes to the wheels. And we use this formula. Looks quite intimidating, but it's pretty simple. So if we just take a look at the first part, we should do is loss dt terms. It simply says how much is the percentage of that you lose from the power that you put into the pedal to the power that you see on the wheels. Usually it's between 1 and 3%. I think it's a good estimate. This term is not very easy to find. We should assume like a 2%. I think it's quite good. If we have a really top high-end bike, probably 1% should be good. So at the end, the power that you should put in the legs is simply using this formula. You should find the power that you should put into your legs to overcome all the forces that we calculated before. So we made a broad presentation of the main forces that are influencing a bike ride and how much power you should put to overcome these forces. So thank you for watching this video. See you next time. Bye.